Okay, and in these few examples right here, what we're looking to do is we're looking to basically use the factors. So what we've been given here is the factors. And from the factors, we want to be able to lead ourselves to the zeros. And then from the zeros, we want to determine if we have any multiplicity. And then utilize what multiplicity would look like to get a sketch of the graph. So essentially what we're looking at here is we kind of start ourselves off and we ask ourselves some questions. We ask ourselves questions like, well, what are our zeros? So in this first one right here, x minus 3, if we listed out our zeros, x minus 3 would give us x equals 3. And that would be with multiplicity of 2. We'd have x equals negative 3, and that would be with multiplicity of 2. So when we graph this, we know it's going to cross at negative 3. We know it's going to cross at positive 3. Okay, so now we have to establish our end behavior. So like, how is this graph going to behave on the end? So we go back to that first video and we realize, well, wait a second, it doesn't have a power function. So now when we establish the end behavior, we had to kind of look at our degrees. We had to say to ourselves, okay, well, this particular term right here has 2, and this particular term right here has 2. If we add our exponents together, that means we have x to the 4th. And so that means that the actual degree of this function would be an x to the 4th function if I thought about my power function. Now if you look out in the front of this guy, you'll notice there's a negative sign. So therefore that means that there would be a negative out in front. So that's my power function. So going back and referencing what we did on the previous video, we realized that if we had an even degree function with a negative leading coefficient, our end behavior is going to be pointing down. So we can come back to our graph and we can say, okay, we've got to pass through these guys right here. We got to do something with these guys, not pass through. We got to do something with these guys. But ultimately, I'm an even degree function with a negative leading coefficient, so this graph is going to be pointing down like so. Okay, so now let's talk about multiplicity. Let's talk about the behavior of multiplicity on a graph. If your multiplicity is even, so if you have an even multiplicity, then you are going to what they call, some people call it touch, some people call it bounce. So in this case here, both of ours are even. So that means that I'm going to come up from my end behavior. I'm going to touch or bounce, come down. I don't really care or want to find out right now. I mean, we could figure out where it crosses the y-axis, but it comes down, it comes back up, it touches or bounces and comes back down. So that's what my graph would look like. Okay, I highly recommend that as a good test taker, that or good learner, that you would plug this in your calculator and verify that it does match up. Moving on to the next guy. To be able to kind of start this off, we go with our zeros again. So that would be x equals 0 and x equals negative 6. So I take the x right here, set it equal to 0. I take the x plus 6, set it equal to 0. I get negative 6. That means this graph is going to cross at 0 and negative 6. If I was to think about my degree, or if I was to FOIL this together or distributed property, I would see that the degree on this guy is 1. The degree on this guy is 1. I add those together to figure out that this would be an x squared. So my power function would be x squared. I go and I look and realize that a positive times a positive is a positive. So that means I'm going to have a positive x squared. So this graph would come down, pass through, turn the corner at some point, and come back up. Now remember, all we're doing is drawing a rough sketch. So you can see here that these two guys are degree of 1. That means they have an odd degree. And if you have an odd degree, then that means that you pass through the x-axis. We go to the next one. We see that we have a second degree. So we got a 2. We've got a 1. It's an understood 1 if there's not an exponent. And then we have a 2 on the last one. We add that together, we have a 5th degree function. So that means that the power function for this guy would be x to the 5th. The leading coefficient, if I multiply this guy times that guy to get that leading term, it would be positive. Now we take our zeros, we take our factors, to find our zeros. So we take x squared, set it equal to 0. That means we get x equals 0 with multiplicity of 2. I take my x minus 2, set it equal to 0. So I get x equals 2. And I take my x plus 5 squared, and I set it equal to 0. And that gives me x equals negative 5 with multiplicity of 2. So when I come up here and I start graphing this, that means I'm going to cross the x-axis at positive 2. I'm going to touch the x-axis at negative 5. And I'm also going to touch at 0. Now the question is to establish what my end behavior is going to look like. Well, I'm a 5th degree function. So I'm an odd degree function. So I come back here to my sketches. So I'm an odd degree function. So I'm going to be going in opposite directions. I'm an odd function with my leading coefficient to be positive. So I'm going to look like this guy right here. So I come back. And that means that this hand is going to be pointing down there, and this end behavior is going to be pointing up there, and I have to somehow figure out how to draw through these. Well, I know that at 0 I'm going to bounce, and I know at negative 5 I'm going to bounce because I have multiplicity. So that means I'm going to come up to negative 5, I'm going to bounce or touch. Sorry about that. I'm going to bounce or touch. I'm going to come back down, and it doesn't really matter to me like how far you come down. You're just drawing a rough sketch. You come back up to 0. 0 has multiplicity of 2. That's even. So I'm going to come back up and bounce or touch. I come back down. I turn the corner again. And this time, I just have a single a single 0 at positive 2. It doesn't have multiplicity, so I pass through. So that's my rough sketches when I'm giving my factors and I want to find my zeros and utilize my multiplicity.